Probability distribution. Probability distribution is really the way we look at numbers and how they are related to each other. This becomes very important in data analysis as we are looking at how these numbers are interrelated. First, there is some vocabulary that we need to have. The mean, or x bar, that is x with a line over top of it, is the average of all of the data points of the distribution. This means that we add up all of the value points and then divide by the number of data points that we have. The median is the middle point of the distribution. This means that there are just as many data points before and just as many data points after. When the number is odd, it is very easy to determine. First, rank the data set, place the numbers in increasing value, then take the number of data points that you have, let's say 9, then add 1 gives us 10, half of 10 is 5, so the fifth number is the median. The fifth number has 4 numbers before it and 4 numbers after it. When the data set has an even number of data points, let's say 10, then the median is really between numbers 5 and 6. Half of 10 is 5, 5 plus 1 is 6. Take the average of the fifth and sixth values and that will give you the median. There is another value called the mode, which is really the value that appears most often in the data set. This can be of interest, but that would really depend on what you are analyzing. The last term is the standard deviation, which is the measured variation among the data set. The formula for the standard deviation is calculate the distance from the average for each data point. Square that, then sum all. Divide by the total number of data points minus 1. Then take the square root. This calculation can be done by most spreadsheets and calculators. This becomes important when looking at distributions. There are different kinds of distributions. One type is a continuous distribution. In the continuous distribution, the data points of the dependent variable can be found in a continuous set. This may depend on the accuracy of the measurement method, i.e. the number of seeds produced by a plant at the end of the growing season. These are whole units, but there is an infinite number of possibilities. When we look at distributions, the most common distribution that is talked about is the normal distribution. The empirical rule states, if the distribution is unimodal and symmetric, then approximately 2/3 of the observations are within one standard deviation of the mean. Approximately 95% of the observations will be within 2 standard deviations of the mean. Nearly all of the observations will be within 3 standard deviations of the mean. This represents a normal distribution. You can see that 68% are within 1 standard deviation. An additional 27% is within 2 standard deviations, and outside of 3 standard deviations is a very small percentage. When the standard deviation is a small value, close to 0, the curve will be tall. When the standard deviation is large, the curve will be flattened. This becomes very important in our analysis of data, as data sets with large standard deviations will tend to have more similarity and therefore will not be statistically different. There may be different ways that the standard deviation can be used to analyze data. We do this if the data sets are similar or if there are differences. Z-scores allow for the comparison of observations in one group with observations in another group. Let's suppose students in one class got 80 on the exam. The mean was 70, the standard deviation was 10. While students in a different class got a 75 on their exam as a mean of 70 and a standard deviation of 5. The question is, who did better? Using the Z statistic, we can compare these. Z equals x minus x bar divided by S. Therefore, 80 minus 70 divided by 10 equals 1. 75 minus 70 divided by 5 equals 1. Since both cases came up with the same Z-score, we can interpret that they were similar. Another kind of distribution is the skewed distribution. Skewed distributions have a median near the one side of the curve. This often gives us a greater value than or less than kind of distribution. You may be testing an interaction between an organism and a chemical. A little bit works well, a lot may not be good for the organism. The inverse could also be true. The last kind of distribution we're going to look at is the discrete distribution. The possible outcomes follow whole number selections. Therefore, there is not a continuum of variables, only yes or no. When you measure something, there are lots of possible numbers and decimal places that could be used. With the discrete distribution, you only have a limited number of choices like yes or no, or maybe a scale from 1 to 5 with only 5 choices. This would be much like a multiple choice question. When asked the question, do you enjoy statistics? The possible answers are yes, no, I'm not sure, or I definitely enjoy them. You actually may have some others in there that you wish to express. You are limited to 4 possible answers, and there are no intermediate points between them. This therefore limits how you analyze this. These are discrete values because there is a limited number of data points. This kind of distribution requires special analysis, such as chi-squared. Chi-squared is often used for genetics where there are normally 1 or 2 characteristics that are available. It is therefore important to understand probability distributions before we begin statistical analysis of any data set.